Here's the solution to one of the odd problems on hypothesis testing. You'll notice there's no context here at all. And what they're doing is skipping us right to the very end of the hypothesis testing process. So they're giving us the null hypothesis and alternative hypothesis really only to give us the form of those, because that tells us whether we're doing one or two-tailed tests. And then they're fast forwarding us to the end of the whole process and giving us that the z-score involved here is 2.53. So without going through the process of setting up the curve and figuring out the standard error and figuring out where our p-hat sits on that curve, they're just fast forwarding us right to the end. And so if you look at the end of our hypothesis testing process, when we get down to like step, whatever it was, step G or H or whatever it was, towards the bottom, where we're drawing, after we figured out the z-score, we're going to draw a picture of it. We can do that. That's all we really need. So here they tell us the z-test statistic is 2.53, meaning that whatever the p-hat was, when they figured out the z-score, it was 2.53. And so I can draw that on my curve. Oops, that's not where it goes. 2.53 would be about there. And so depending on the alternative hypothesis, we would shade the picture in different directions. So in Roman numeral 1, they're saying consider the alternative hypothesis to have a greater than symbol. And like I said in class, you can think of the inequality symbol as telling you which direction to shade. So a greater than symbol means shade to the right. So this would be, the shading would be the p-value that I need. So whatever the area, p-value is the area of that shaded bit. For the two-tailed distribution, or sorry, two-tailed alternative hypothesis, I would draw my, the 2.53 would still be there, but I would also draw the mirror image. So I would draw it 2.53 and negative 2.53 and shade both tails. This is my two-tailed hypothesis. And so again, the p-value would be the area that you see there. And then in the third case, where we have a less than statement, this would be shading to the left, but again, it's still at 2.53. So this one will look weird because it's not really a tail, but that's technically what it says to do, is draw my line at 2.53 and then shade to the left. So in each case, the p-value that they're asking about is just going to be the area of these pictures, and we know how to do that with our table. Since I have to do all three, I'm going to do the easiest one first. Well, I guess 2 and 3 are both easier than 1. The reason that 1 is not easy is because the shading goes in the wrong direction from our table, so I'd have to think about that. But let me do the one that's easier. So number 2 is not bad because I can do this part easily. I can look up in my table z equal negative 2.53, and the table will tell me how much area is to the left of that. There's a cat on my lap. The table, when I look that up, the table, well, we'll look it up in a second. Whatever the table value gives me, then the p-value will be twice that, because I have that on both sides. For number 3, if I look up z equals 2.53, then the table is going to tell me how much area is shaded to the left of that, which is what I want. So that, whatever the table says, that'll be my p-value. Here, this is my... the blue one is the hardest one because the shading goes the wrong way, but notice that, that the amount of shading to the right of 2.53 is exactly 1 minus the amount shaded to the left of 2.53. So if I do this one first, then the amount of blue area over here is just 1 minus the amount of green area. But also, the amount of red area I have here is equal on both sides. So this amount of red area is exactly this amount of blue area. So really, whatever answer I got here when I looked up negative 2.53 and doing this problem, that would also be the blue area. So I can really just look up the negative 2.53 and the positive 2.53 and then figure out the answers to all of these all the way across. And the reason I'm not answering them here is because I don't have a table in front of me, but I'll get the values from the table on the next slide. So here's a table. If I look for, well, did I even include enough to see it? I did not. Oh, I know why. I thought it was 2.35. Okay, well, I can get this one, so this will be good enough. If I look up negative 2.53 here, negative 2.53 will be this value. That doesn't show up very well. This value right here. Right, there's, so 0.0057. That's how much area is to the left of negative 2.53 on the curve. So back to this picture. Negative 2.53, the amount of area. The amount of area that's here is 0.0057, which means the amount of area here is also 0.0057, which means the amount of area here is also 0.0057. And then this one will be a little different. For this, I need all the area over here, and that'll be 1 minus 0.0057. Or alternatively, I could just look up 2.53 in the table. So this is 0.9943. So the p-value in the middle one is the sum of these two, 0.0114. This one, that is the p-value. So I have the p-value in each case. I would say when it's asked, would any of these be considered small? They're not really telling us here what they think small means, but I think it's fair to say that that these two would both be considered to be quite small. This is a little more than 1%, and this is around half of 1%. So I think in either one of the cases, both these two would say that the p-value is small enough to warrant having evidence against H0. This one obviously is not remotely small. But again, they're not giving us a significance level here. They're really just trying to get us to think about those last steps in the process, and then just sort of think about whether the numbers we're getting would be considered small or not. So anyway, that's how that goes. Without the context of a problem and without doing steps A through J, it's easy to lose track of what you're doing. But all they're really trying to test is just this part that comes up at the end. It's sort of like parts G and H that we do on our worksheets, just going straight to that.